Here's an example. Theta is negative 3 pi. Find the exact values. Secant, cosecant, tangent, cotangent. Well, first off, we need the definitions. The sine of an angle is the y on the unit circle. The cosine is defined to be the x. Remember, they just made this up so that sine and cosine would be periodic cyclical functions to represent things in the real world which are cyclical. Tangent, so it's all about sine and cosine. That's why we have those right on the unit circle. And the other 4 trig functions all come from sine and cosine. So tangent is just sine over cosine. And then the other 3 trig functions are just Johnny-come-latelys. They are just made out of the first 3. They're all reciprocal functions, meaning they're upside down. So the cosecant, that's 1 over the sine. The secant, that's 1 over the cosine. And the cotangent, that's upside down. Tangent, so it's cosine over sine. You see that sine, and then this is upside down. Okay, so let's get back to it. So what's our angle? Negative 3 pi. That's our angle. This is theta, and they're telling us theta is negative 3 pi. Well, negative 3 pi, we're not going to find that on the unit circle, right? Here's the unit circle. There's no negative angles, right? We only have positive angles on the unit circle, no negative angles. So how are we going to do this? Well, we've got to make it positive. Remember, you can always, let me write this out for us. We can always add or subtract 2 pi because it is 1 full rotation, so we end up at the same spot on the unit circle, right? If you add 1 full rotation to where you were before, you're going to end up at the same spot you were at before. So we can always come in here and add 2 pi. What happens if we take negative 3 pi plus 2 pi? We get negative pi. We're still negative. All right? Well, let's do it again. Let's take negative pi and add another 2 pi. What do we get? Positive pi. There we go. So I added 2 pi twice. You can add 2 pi as many times as you want because it's just 1 full rotation. You're going to end up at the same spot you were at before. You don't change the spot. It's the same spot on the unit circle whenever you add or subtract a full rotation, 2 pi. So I added 2 pi twice, and that changed my negative 3 pi to positive pi. That's the same spot. That's where negative 3 pi really is. It's the same spot as positive pi. So let's go find that spot. And specifically, we need to get sine and cosine. So positive pi, it's right here. Whoop, I attempted to put sine first. Cosine first, then sine. They made cosine the x, sine the y. I don't know why they did it in that order, kind of a backwards order. Cosine coming first, and then sine. Cosine is negative 1, sine is 0. So cosine is negative 1, sine is 0 at pi. So let's plug in the information then. Tangent is sine over cosine. It's 0 over negative 1. 0 on the top of a fraction is just 0. Next one, 1 over sine. This is 1 over 0. What is that? Does not exist. Do you know about that? You can't have 0 on the bottom of a fraction. That does not exist. Cosine, that's negative 1. 1 over negative 1, that's just negative 1. And finally, cotangent, which is cosine over sine, it's negative 1 over 0. And there it is again, 0 on the bottom of a fraction does not exist. It's actually infinity, right? Because 0 goes into any number infinite amount of times. And that does not exist. There's not a real number that exists there. So 0 on the bottom of a fraction, notice, is always does not exist. Does not exist. So there we go.